Hello children, you're welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I am Uncle Agbaje. Today in mathematics, we are not done with binary numbers. So we're just going to be working on binary numbers like we did in the previous lessons. But as is our usual practice, we'll begin with correction to the previous assignment. In the last lesson, you were asked to change these numbers to base 2, and you were asked to add these two. So let's take the correction one by one. Changing 66 to base 2 rather. Remember that all we have to do is subtract all the place values, the binary place values from 66 until we get to 0. So let's just do that. That's 66. Now 64 will be subtracted from 66. That is the largest place number that can be subtracted. Subtracting 64 from 66, we get 2. Now, after subtracting that, we have 32, which cannot be subtracted, 16, 8, 4, then we can subtract 2. So subtracting 2, we're left with 0, and that's the end. But we're able to subtract 164, and then we're able to subtract 1, 2. So put 1 under 64 and 1 under 2, and every other space will be filled with 0. And so 66 base 10 is the same as 100010 in base 2. Did you get it right? Good job, you. Let's check out the next one. This one says we should change 41 in base 10 to base 2. So we're going to subtract. 64 cannot be subtracted, so we'll subtract 32. And when we subtract 32 from 41, we get 9. Now from 9, we can subtract 8. So subtracting 8, we get 1. And then from 1, we can subtract 1, we'll get 0. That's the last stop. Now, we're able to subtract 132, 18, and 1, 1. So put 1 under 32, 1 under 8, and 1 under 1. The remaining spaces will be filled with zeros, which are the placeholders in this case. And finally, 41 in base 10 is the same as 1001 in base 2. I trust that you got this right. Let's check out the one with the addition now. We're going to add 1101 in base 2 to 1100 in base 2. So we just arrange it as normal, you know. Now adding 1 to 0, we get 1. 0 to 0, we get 0. Now remember, 1 base 2 plus 1 base 2 is 10 base 2. Then we carry 1 to the next base. 1 base 2 plus 1 base 2 is 10 base 2. And plus 1, that's 11 in base 2. But remember to write that TW0. Did you forget? Well, I'll pardon you for today, but subsequently, always remember to put the TWO to indicate that this is not a base 10 number, that it's a base 2 number. Did you get all correctly then? Then I give you a chair. Now, are you ready for today's work? Let's check out what it's all about. Our learning objectives will be that by the end of the lesson, we should be able to subtract binary numbers without borrowing. So, we're done with addition. Now we're going to be subtracting binary numbers. We should be able to subtract binary numbers that involve borrowing from another place value, just like we do in base 10 subtraction. And finally, we should be able to multiply base 2 numbers. Are you ready for how it's going to be done? Let's get a sneak peek. Subtraction of binary numbers will come first. Now remember that 1 base 2 plus 1 base 2 is 10 base 2. Then 10 base 2 minus 1 base 2 is 1 base 2. So this is what we're going to be working with. 10 base 2 minus 1 base 2 is 1 base 2. Oh. With that at the back of our mind, let's start with the first example, which says, evaluate 1110 in base 2 minus 1010 base 2. So we're going to arrange as normal. Okay, remember to put the subtraction sign. Now, starting with the ones, 0 minus 0, of course, is 0. I mean, this is easy stuff for you. 0 minus 0 is 0. Now 1 minus 1, even in base 2, 1 minus 1 is 0. Yeah. Now 1 minus 0 is not 0, it's 1. Alright. Now 1 minus 1 is 0. See, this one is simple. No need to borrow anything. It's just as you do it in base 10. But this preceding this leading 0, we don't need it. We don't start a whole number with 0. So we just cross out that one and remember to put base 2 at the end. Easy peasy, right? Well, it's not always going to be easy like this, okay? Let's check out some other examples that involve borrowing. This example asks us to evaluate 10101 in base 2 minus 1110 in base 2. So we're going to arrange as usual using the place values. Remember to put the subtraction sign on your base 2. Now we start from the ones. 1 minus 0 is still 1 in base 2. Now 0 minus 1 is not going to be possible even in base 2. So we have to go to the next place value to borrow a 1. Now when we borrow a 1, we're left with 0 here. So remember to put that 0 on top. When you remove 1 from 1, you're left with nothing. So that's 0 up there. Now the 1 that you borrow goes here, 10. It becomes 10. Now 10 in base 2 minus 1 base 2. Remember? 10 base 2 minus 1 base 2 is 1 base 2. Alright, so we're done with that place value. We'll come to the third place value. Now we have 0 minus 1, which is another problem. And then we want to borrow from the next place value, but we don't find even a 1 there, which is another problem. And so what you do is that since we cannot get 1 from here, just like we do with base 10, we have to go to the next place value until you get a 1. So we can't get 1 from here, so we'll go to the next one. But when you borrow 1 from here, you don't take it directly to where you're coming from. You have to give it to the next one, you know, before borrowing from there. You're meant to borrow from here, but if this man does not have a 1, help him borrow from here, let him have, then you borrow from him, okay? So that's exactly what we're going to do. So we borrow 1 from here and then we're left with 0 and give it to this man. Then we borrow 1 from this man, and when you borrow 1 from 10 in base 2, 10 base 2 minus 1 in base 2, remember that you'll be left with 1. Now the 1 that you have borrowed from here, you're going to put it beside the 0 here. Now you have 10. Now 10 base 2 minus 1 base 2 is 1 base 2. Then 1 base 2 minus 1 base 2 is going to give you 0. And then this 0 comes down. Now, these two zeros are unnecessary. Your answer is 111 in base 2. It is your turn. You are to evaluate 1101 in base 2 minus 1011 base 2. I'll give you 1 minute. That should be enough, and I'll be back to show you how it's done. Alrighty then, were you able to get it easily? Let's check it out. The question says, evaluate 1101 in base 2 minus 1011 in base 2. So we arrange it as usual. Now, starting from the ones, 1 minus 1 gives us 0. Now 0 minus 1 is not possible, so we'll go to the next place value to borrow 1 so that we can make it possible. And then this is borrowing 1, you have 10. Remember that when you borrow 1 from 1, you're left with 0. So now in base 2, 10 minus 1 in base 2 is 1 base 2. Good. Now 0 minus 0 is 0. 1 minus 1 is 0. And so these two zeros are unnecessary, so just cross them out. And then you're left with 1 0, 10 base 2. So remember to put base 2. This, I believe, is the answer that you got, my friend. Good job, you. Now let's look at how binary numbers are multiplied. This first example says that we're to evaluate 110 in base 2 times 11 in base 2. Now, multiplication is in base 2 and base 10 is the same method, but because numbers in base 2 are basically ones and zeros, I will just be using the Japanese method that I explained in the Magic Tuesday yesterday. But if you're not comfortable with that method, you can use any other method. You will still get the same answer, just as long as you remember that 1 base 2 plus 1 base 2 is 10 base 2. All right, so multiplying 110 base 2 times 11 base 2, right? 1 bar, and then this other bar that is having dashes is representing 0 bar. Now we'll cross it with 1 bar and 1 bar. And this is 1 1. So this is 1 1 0. Now what we do is that all the points along the dashed lines, we just put 0 there because we will not count it. So we'll put 0 there like this. So 0 0. And all the other intersections we put 1 1. Then we add diagonally as we normally do. So here we had 0 is going to be here, and 0 plus 1 is 1, 1 plus 1 is 10 in base 2, and we carry 1 to the next place. 1 plus 1 is 10 in base 2. So it's basically the same method. So our final answer now is 10010. You read this way. So therefore 110 times 11 in base 2 is 10010. Let's check out another example. Now this second example says that we should multiply 101 in base 2 by 101 in base 2. And that's basically like saying 101 in base 2 squared. Okay, so in case you come across something like that, just expand it. Now, how do we represent 101? A single line for 1, a dashed line for 0, a single line for 1, like this. 1, 0, 1. Then another 101 will cross it. So 1, dash line 0, a dash line 1. Now, along the dashed lines, just put 0 at all the junctions along the line. This is one dashed line, so you put 0 here, 0 here, 0 here. And this is another dashed line, so you put 0 here, 0 here, 0 here, like this. So along all the dashed line, you put zeros there because we're not supposed to count them, okay? And then for all the other points, you put 1. 1, 2, 3, 4. The next thing to do now is to add diagonally, and I'm going to draw circles to guide you. This is diagonal, 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 and diagonal. So let's go, yes, like that. So this is 1, 2, 3, 4, 5, diagonal. So you add what you find inside each circle and put the answer right at the end. Here you have 1, and here 0 plus 0 is 0, and here 1 plus 0 plus 1. Here 1 plus 0 plus 1 is 1 plus 0 is 0. 1 plus 0 is 1, then plus 1 in base 2. Remember, that's 10 in base 2. Now you can't have 2 digits here, so you have to carry 1 to the next place, which is the next circle. Now you have 1 plus 0 plus 0, and at the end you put 1, because 1 plus 0 plus 0 is 1. And here you have just 1, you have 1. So now our final answer is 11001, not forgetting to write base 2. I hope that you understand that. Now I'm sure you're ready for classwork. Well, there will be no classwork, just homework for you to practice. And if you submit your homework, then you get a chance to win packs of Good Life Magic Juice. And that homework comes up right about now. You are to evaluate 11000 in base 2 minus 1011 in base 2, and also 111 in base 2 to be multiplied by 10 base 2. Don't forget that you can still get a chance to be a part of the program. You can take a video of yourself doing this and send to us, and you may get a chance to be shown on the program. Now it's time to hand you over to Uncle Popo for the General Studies lesson. Till I come your way in the next lesson with more interestingly packaged lessons. Remain wonderful mathemagicians.